This afternoon's lesson is all about, it's kind of an introduction to measuring the speed of things. So I'd like to start by telling you a little story about this man here in the picture. His name is Donald Campbell, and he was famous in the 1960s. I told my dad about this lesson, and he says, "Oh, I remember Donald Campbell. We were watching him on telly in the 1960s," which tells you how old my dad is. And Donald Campbell was right here. He was a bit of a massive speed freak. So he was into breaking world records. And he had 2 world records in the 1960s. He had broken the land speed record with a car that was, I think it was sort of something like 500 miles an hour or something ridiculous with his car. His dad had done the same thing, Malcolm Campbell, in the 1930s and broken all those land speed records. But he also had a boat. Probably his favourite was his boat called Blue Bird. And he'd broken the world water speed record. Now, I've got a little picture of the boat here. And nobody had ever had both records at once, so he was quite special. Donald was a record holder in both land and water. So this is his boat here. This is looking at it from the back end of the boat. Can anyone want to type anything that I see is quite unusual for a boat? It looks a bit of a strange looking boat. I've got more pictures later on, but anyone spot anything a little bit unusual about this boat? You can obviously see why it's called Bluebird. Ewan. That's right, it is. It looks a bit more like a rocket than a boat, doesn't it? So, this bit here is the back of a jet engine. So if you've been flying somewhere and looked out the window, and you'll see most aeroplanes these days have jet engines, this boat has a jet engine to it. So it had fire coming out the back, and that was how it got up to speed. So it was a world record breaker because you don't get many boats with a jet engine on the back. And that's what Donald Campbell was using to try and bust the record. So what else do you notice about the boat? How do you know that? I think it is probably illegal, Ewan. Yep, you're right. How do you know that this was a boat designed for speed? Just looking at the picture here, how do you know this was designed for going extremely quickly? I don't think there are many boats that look like that. But what do you need to do to something, a boat or a car, if you want it to go very quickly? Charlotte's not sure. Ewan's worried about the jet engine exploding. Think about the difference between like a car that is... Oh, Hannah. You're absolutely right. Hannah's got there. So this boat was extremely streamlined. There was a cockpit right at the front. I'll show you another picture where the pilot sat, Donald, but most of the rest of the boat had very smooth features to allow it to go through the air very quickly. So that's called streamlining, and we'll talk about that perhaps in the next lesson. We'll talk about streamlining and friction as well. But yeah, this boat was extremely streamlined. Now then, so here are the rules for breaking the world record. So let me just take you to... I've got a little map here. So Donald Campbell was taking his boat, Bluebird, to this lake here, which is in the Lake District of the UK. It's called Lake Coniston, and it's in the 1960s. And it was if you've never been to the Lake District, it's one of the most beautiful places in England. And the lakes there are very long, the longest lakes in the UK. And Lake Coniston was where he planned to do his world record attempt. And they had measured out a 1 kilometre distance. So on the lake here. So I've got a little map here. Let's just type in Coniston. Alright, so here we go, zooming in on England. And that's the village of Coniston. And I actually wanted the lake which is near to the village. So here you can see the lake just here, and you can see Coniston Water, it's called, It's a pretty long piece of water. And it was about 9 kilometres long. And somewhere in the middle here, they had marked out with flags a 1 kilometre distance. So who can tell me how many metres are in 1 kilometre? So this is it's about 8.8. It is pretty big, yeah. It's like this district up here, this part of England, Isla, it's called the Lake District. It's full of beautiful mountains to climb, and there's Liverpool in the background, and lakes as well, so you can see it's quite mountainous. Ewan, that's right, there's 1,000, Hannah, 1,000 metres in every kilometre. So when I say this lake here was 9 kilometres long, just about 9 kilometres, that means it's 9,000 metres long. And when they marked out on the middle of the lake a 1 kilometre section, then we're talking about 1,000 metres of section. And the idea is that Donald Campbell would come to this end and then turn around and then pick up speed, and when he was going at top speed, he would go past the first flag, and then he had to go 1,000 metres, 1 kilometre, to get to the second flag, and they would time the distance between, time how long it took to do that 1 kilometre. And that was how we would break the speed record. Or at least try to break the speed record anyway. So here we go. So he's on his lake here, and there were some people with a stopwatch at both ends. And this is his boat. This is an actual picture from the 1960s as his boat was started to move. And he was aiming, the record was 480 kilometres per hour. Now, if you're not used to talking about speeds, you might not know how quick 480 kilometres per hour is, but it is very rapid, very speedy. And we'll do a little bit more maths in a second. Now, that reminds me, has anybody got a calculator handy? So if you're watching it on your phone and your phone is your calculator, then you might not be able to do the calculations that are just coming up, but we are going to do a bit of maths. So if you're watching on your computer and you've got your phone handy, then switch it to calculator mode. Or if you've got a calculator handy, I should probably said this at the beginning of the lesson, then just grab a calculator. I'll give you a bit of time to go and get a calculator. A few people have got calculators, that's excellent. So, yeah. Alright, you can always have a go at these later and watch the video back if you can't find your calculator right now. Good. Okay, so they've marked out this 1 kilometre, and remember 1 kilometre is 1,000 metres. That's really important. So we're going to do a bit of distance conversion now. So there were some other lakes in the Lake District that he could have chosen. Lake Coniston, the one that we've just been talking about, is 8.8. Ewan's doing a little bit of conversion there. That's right, Ewan. 480 kilometres per hour is roughly 300 miles an hour, and that was what he was going for with his boat. Ewan, how did you do that conversion? Did you ask Google? Did you say, Google, what is 480 kilometres per hour in miles per hour? I think, let's see if you can sort of ask, okay, Google, what is 480 kilometres per hour in miles per hour?
480 kilometres per hour equal 133.333 metres per second.
Yeah. Well, that wasn't that great because the answer came up in my kitchen, so that's what it's not supposed to be. But yeah, so you can ask Google about this stuff. I've got other people's Google going off. Sorry about that, guys. So hopefully I want to show you today how to do that sort of thing by yourself without the help of Google, because Google's taking all the work out of things, and teachers love to make you do a bit of work as well. So anyway, right, guys, so what I'd like you to do with your calculators is just a little task here. We've got 4 lakes: Coniston, Windermere, Ullswater and Bassenthwaite. They're all lakes in the Lake District, and 2 of them I've told you what the length of the lakes in kilometres is, and I would like you to work out how many metres that is. Alright, and 2 of them I've told you how many metres they are, and I would like you to work out how many kilometres of length they are. So in your calculators, Who can tell me if you want to remember? There's 1,000 meters in every kilometer. So if Lake Coniston is 8.8 kilometers long, to convert kilometers into meters, you have to multiply by 1,000. So we've got some different answers here. Can you have a house tour? Well, no. I'm doing my videos on a green screen. I've got a little room with my computer in next to my kitchen, so that's where I am at the moment. Can't give you a tour right now though. Alright, so Ewan's typing some numbers in here. So, okay, good. So Ewan, let's do these two first. So this one here, if you take 8.8 kilometers and to turn kilometers into meters, you need to times it by 1,000. And I think I have a little, let's bring my old calculator up here. Here we go, can everyone see my calculator? Alright, okay, so if the lake is 8.8 kilometers long, 8.8 times that by 1,000, and that's how many meters it is for this lake. So this lake is 8,800 meters. So you need to get used to turning kilometers into meters and backwards again, and the other way around. So, hello George. We've got Odd Animal as well. Who's Odd Animal? Good afternoon. And Grace is here. Oh, Evelyn's here. Good afternoon, Evelyn. If you weren't here from the beginning of the video, guys, you'll be able to watch the video back again later on YouTube. So, Isla, so do not worry if you're not sure about this. So I know you're not very confident with your math. So every time you've got kilometers, so kilometers is a measurement of distances. So it measures 1,000 meters. So if you say, oh, that's 8 kilometers, then people are actually talking about 8,000 meters. So remember the lake here, this lake was nearly 9 kilometers. 9 kilometers long. When somebody says 9 kilometers, they're talking about 9,000 meters. So to do the conversion, it is a little bit of a maths class, Ewan, but remember there's a lot of maths in science, especially when you're talking about speeds and forces and so on. So don't worry, if there's a bit of maths, then that's good too. So yeah, so if we've got 8.8 kilometers, times that by 1,000, and that means it's 8,800 meters. All right. And to do these two, I saw Ewan posted me the answers earlier. You have to do the other way around. So if you have a certain number of meters, so 11,800 meters, then you have to divide by 1,000 to get back to kilometers. So let's just bring the calculator up here again. So if you've got, so this one here, Ullswater is 11,800 meters. So let's just type that into the calculator, 11,800. And you have to divide by 1,000 and you get to 11.8 kilometers. So if you've got to be comfortable and sort of do a bit of practice. Amber Dawn got 61 out of 19 on her maths homework. Now that is incredible, Amber, because let me work that out as a percentage. So 61 divided by 19 times 100, that's 321% in your maths homework. So very impressive. I bet your maths teacher was pretty impressed about that. I'm not even sure that's possible to get 321%. Hannah reckons her little sister is a sweat. Totally agree, Hannah. That's a good thing. Right. So changing kilometers into meters was something that really important that they need to do to break the record. Now then, I'm going to show you. So I'm going to show you a little clip here with sound. It's a video clip from a TV program that was recreating the attempt. So remember, he's trying to speed up to 1 kilometer on Coniston Water and trying to break the record. So let's have a look here. I'm going to turn the mic off when this is playing because Otherwise, we're going to get weird sound feedback effects. So it's about 2 minutes long, and this is how Donald was making his world record attempt.
Base to all stations, 0842 hours startup. Repeat, 0842 hours startup. Over.
Stand by, here we go.
Okay, I'm ready.
Skipper to all stations. Maintain radio silence. Over. Planing up. I'm ready to give her the gun. Here we go. I'm up to full power now. The G-first marker. First marker. I'm breaking my pedal here. She's steady. On the second marker. Coming down off planing. Easing off power. Come in base. What was my speed? Over.
Alpha to Tango, confirm speed please, first run.
Tango to Alpha, plus 47. Repeat, plus 47, over.
Plus 47. What's plus 47 mean? It's very short. 297.
Can you see him?
297.
He's
I haven't done that.
Hey, come on, Donald.
I can see Louis on the refueling boat. Over.
Alpha to Charlie, stand by for refueling, over.
All right, so that was gives you an idea of what was actually going on. And what I hadn't said really is that just how brave Donald Campbell and other people who were looking to break the records had to be. They were doing something that was extremely dangerous. And Isla said, I would quite like to have you on that boat. Well, you'd have to put yourself up to quite a lot of risk, Isla, if you were on that boat. There were people that had died trying to beat the world record on both the land one and the water one, and it was you had to have like an obsession with trying to get faster and faster, obsession for speed. 300 miles an hour that we're looking at here is incredibly quickly, and I hope that video gave you a little bit of an idea of what that would feel like. That's Evelyn, isn't it, with Odd Animal 122 is talking about how many G's that would be. So G's are when you're speeding up or slowing down, Evelyn. You feel yourself pushed back in your seat, and that's called G-force, and that's when you're speeding up or slowing down. So, so he was certainly accelerating quite quickly, speeding up to get up to speed, and that's when he would have been feeling what's called the G-force. We'll talk about G-force actually when we do a lesson. We're going to do a lesson on acceleration as well later on. So, That was the excuse me. That was the boat so far. So let's have a quick look. So this is Donald Campbell. Here he is, this guy, making this world record attempt across Coniston Water. And here's Coniston Water. And he had to go 1 kilometre. And 1 kilometre is 1,000 metres. So now we need to do a little bit more maths. So here he had, I've written out in this table here. And if you've got pencil and paper, then you could just jot a couple of these down. But if you don't have pencil and paper, don't worry too much about it. Just use your calculator if you've got a calculator. So, how do you work out how fast Donald was going on each of these little tries here? So, I've written out in this table: first try, second try, third try, fourth try. So he did 4 runs, and the way that you, well done you, and that's excellent. The way that you, and remember you'll be able to see all these slides later on at the end of the lesson, so the way that you work out how fast they were going is you have to do this. You take the distance that they travelled, so 1,000 metres, and divide that by how many seconds it took for them to do the distance. So if Donald did 1,000 metres in 9.4 seconds, then I'll do this one. You can go and, if your calculator's downstairs, Eiley can go and grab it if you like. So I'll do the first one for you. So here we go. So the first try he did 1,000 metres, and you need to do the distance 1,000 divided by time. So you divide it by 9.4. Okay, and that gives you your speed. And because it's meters of distance in Amber Dawn, you've lost your status as being a sweat. So if it's 1,000 meters in 9.4 seconds, then the speed is measured in m-s, which stands for meters per second. It's how many meters he was going every second. And so the answer here was that for the first try, he was going at 106 meters every second, which is pretty amazing speed, 106 meters per second. So I've done that one for you, so that's just filled in here. So I'd like you to just take a few seconds to have a go at, oops, didn't mean to do that. Take a few seconds to have a go at doing some of these next ones here, and then I'll show you the answers that I get as well. I'll work it out on screen here with you guys. So go and grab your calculators. You have to do the distance here divided by the time each time. So just while people are calculating, does anyone want to have a look through and have a guess which of these do you think was the fastest attempt? So he was always going at 1,000 meters. He was always going the distance because that was a fixed distance. They had marked it out with flags. But every time he did it, he did a slightly different time, how many seconds it took him. So which one do you think is the fastest out of these 4, just while people are working things out? That's good, Ewan, well done. All right, Hannah, why do you think it's the third one that's the fastest? You might have already calculated it actually, so you might be looking at the numbers and you see that's the highest number. But could you have done that even without calculating? Why do you think that one looks like it's the fastest just by looking at the numbers here? Can you explain? I know it's difficult to explain just by typing, but so George, imagine this. If you're not sure about this, so imagine 4 people trying to run a 1,000 meter running race. Okay, and then here's the time it took them to run that race, and you could. That's right, Hannah. So the one that's going the fastest, Evelyn, that's good, excellent, well done, is the one that took the least amount of time. So this one here, the third try, only took 7.4 seconds, so they must have been going the fastest. It's the lowest amount of time. And the slowest one is the one that took the longest amount of time. So that's this one here, the second try. It took 13 points. Maybe his engine went wrong or didn't sort of accelerate properly on this one or something. But so this one should be the slowest amount of time. Okay. So if you've had a bit of a chance to just type that into your calculator, so let's give this a little bit of a try. So remember, every time you have to do the distance divided by the time. So let's just see, for the second try here, we've got to do 1,000. I'm going to make my calculator a bit smaller. There we go, hide that here. So I want to do 1,000 divided by 13.2. And that gives me, well done, a few people were typing that in chat earlier, 75.7. Now what I've done here, guys, I'm sure you've done this in maths before, is that when you have a really long answer like this, you need to do a bit of rounding, and I'll talk about this maybe in another lesson later, but what I've done here is I've rounded it to 1 decimal place, this number, which means shortening it a little bit, and you have to read the number until you've got to the first decimal place. Page, you don't have to write this down, you'll be able to have a look back on it and have a look back on the video later on if you want to, and there's a little quiz that you can do after the lesson as well. Evelyn, could the boat create a sonic boom? That is a great question. So you create a sonic boom when aeroplanes usually go faster than the speed of sound, and the speed of sound is 333 meters per second. So just check I'm right about that. I don't want to be telling you a load of nonsense. So 343 meters per second. All right, so so that means that Donald Campbell's boat, because his boat was going not at that speed, you need to go up to 343 meters per second to break the speed of sound and to make a sonic boom. Now, later on, there were some cars that started to go faster than 43 meters per second, and they were called supersonic cars, and they would have created a bit of a boom as well. So, yeah, supersonic means faster than the speed of sound. Good question, though. So just let me talk about this rounding business. So here, if I want to round this to, some of you might be really good at rounding numbers, so bear with me while I just explain this a little bit. So if you've got 75.7575, you just chop it off right here. So I just use my mouse. Chop it off right here. So chop off all the numbers that are in blue. And then, and you look at the first number that you've chopped off, if it's 5 or more, this one has to go up by 1. So this one goes up to 75.8 when I'm rounding it. All right, let's do a couple more. So the third try, this one we thought was the fastest, was 1,000 divided by 7.4. This gives you 135 meters per second. So that one was pretty quick. 135 meters per second. That was our fastest attempt. And, right, okay, George says that planes normally take off around about 184 miles per hour. So, miles per hour. The tricky thing about speed, George, is that although it's easy to work out speed, you just do distance divided by time, we're doing this right now, it is measured in some different sorts of units. So here, we're looking at meters per second, and that's not the same as miles per hour. So you need to sort of like either ask Google, like we did earlier, to do a conversion, or you need to know how to do a conversion yourself, which I'm going to show you in this is the last part of today's video. All right, so this one was 135, and the fourth try was 1,000 meters in, some of you might have had to get this already, so 1,000 divided by 8.6. And there we go, so that's 116.27, and here I'm going to round that up to 116.3 meters per second. So rounding all these numbers here. So yeah, the fastest one, those of you that said it was going to be the third try were correct. So this was the fastest try. Now, so that was his quickest, 135 meters per second. Now, if you're not sure how quick we are talking about here, 135 meters per second. So usually you can measure out a second by saying 1 elephant. That's a rough guide. And if you say 1 elephant, 2 elephants, that's around about 2 seconds. That's a rough guide to 2 seconds. So 135 meters per second, which means every second he was going 135 meters. So if you imagine saying to yourself, 1 elephant, and in the time it took me to say 1 elephant, Donald Campbell's boat had gone this far around a racetrack. If you've ever raced 100 meters, then it'd gone that far around. So 135 meters in just 1 second. So that's what we're... that's how fast his boat was going. All right. So yeah, as you saw in the video, it looked pretty quick as well, and dangerous. So the last, so what have we done so far in today's lesson? So let's just recap a little bit. So the first thing I showed you was we were talking about kilometers and meters. So if you say something is 8.8 kilometers long, then to turn that into meters, you need to multiply by 1,000. And if you say something is 6,400 meters long, to turn that in, if you want to know that in kilometers, you have to divide by 1,000. So one thing I'd like to practice is changing, and have a look back at this table here if you want to have a practice, changing kilometers into meters and the other way around. Converting units, that's called. And you get more confident in it as you just, with a bit of practice, really. Hello, Tommy. Nice to see you. So, the next thing we've looked at today is we've talked about how you work out the speed of something, and this formula here is something that you need to try and remember. So it's always the distance that they've gone divided by the time, and this one you have to sort of learn this one. Speed equals distance over time, and it's something that you have to sort of like get into your memory. Again, just more practice you do, the better you get at it. So here it was always 1,000 divided by how much time it is. So that's the two things I've shown you today. The last thing I'm going to show you today is probably going to be quite difficult, actually. But if you're not sure about this, then don't worry too much about it. If you've got the first two parts, then converting units from kilometers into meters, that's great. If you got this bit, how to work out the speed and stuff, if you've been practicing it with your calculator, that's excellent. But the last thing is, did he actually break the world record? So, right, this is where it gets a little bit trickier. So his best speed, we already worked out, was 135.1 meters per second. Okay, and he knew the world record he had to beat was 480 kilometers per hour, and that's a different type of unit. So, the first thing we're going to do is, if it's 135 meters per second, and Hannah asked, did he actually break the record there? Family palm trees, you're right. I think that's something called the Bloodhound SSC. We'll talk about the fastest land vehicle in the next lesson, actually. But and aren't they based in Essex? I think they are. Let's just have a look. Yes, this is the one, Bloodhound SSC, or it used to be called Bloodhound SSC. I think they're based... I'll find out a little bit more about them, actually. Supercar Bloodhound, aiming to break the land speed record. We've got another lesson on this, so we'll have a look at this later. So, just talking about whether they've broken the record or not. So Hannah asked, 135 meters per second. So if you want to turn that into kilometers per second, 135 meters per second, how many kilometers per second is that? You need to divide that number by 1,000 to make it kilometers. So who can pop that into a calculator and tell me what you get, and I can write it in this box here. Some of you guys are Googling the fastest various different things. The peregrine falcon, you're right, Evelyn, is the fastest bird in the world. It dives onto its prey, surprises them. All right, Hannah's popped that into her calculator. Well done, Hannah. So let's just check she's got the right answer there. So if you take 135.1, 135.1, divide by 1,000, and you get this one. Well done, Hannah. So this is how many kilometers per second it is. So let's just, oops. Just need to write that in this box here. So it is 0.1351. Okay, so that tells you that it's going at 0.1351 kilometers every second, which sounds a lot less fast than, but remember that that's about 1/10 of a kilometer in every second. So that's just measured the same speed, but measured in kilometers per second rather than meters per second. So if it's going at 0.1351 kilometers per second, how fast would it be going? How many kilometers would it be going per minute? So if it does this number of kilometers every second, how many would it be going per minute? And the key here is you need to know how many seconds are in a minute. And so take this answer here and times that by how many seconds are in a minute. Let's see if somebody can type that into their calculator. George is Googling the speed of different items. Well done, Hannah. So if it's gone this many kilometers in a second, then you have to times it by 60. That's right. So let's just bring this up here. So take that answer, times that by 60, because it will be doing 60 times the distance if you time it for a minute than if it was just going for a second. So times that by 60 and we get 8.106, and that's the kilometers per minute. 8.106. Let's write that in there, here. All right. And finally, if we wanted to work out whether it had broken the speed record or not, if it goes 8 kilometers every minute, now 8 kilometers is probably distance between you guys and like Southend Town Centre or something like that. So if it gets from here to there in a minute, that's going pretty quickly. What about how far that would go in 1 hour? That's called kilometers per hour. So here again, you have to know how many minutes are in 1 hour. So most people know that's 60 minutes in 1 hour. So if we take this number here and multiply that by 60, again, we'll get how far that is per hour. So that number times by 60. Some people are writing it in chat already. So that gives us our final answer. Donald Campbell was travelling at a speed of 486.36 kilometers per hour. 486.36 kilometers per hour. Nice. Okay, so we've worked out that on his third try, which was his fastest one, we've done, this is called converting units here. So we've had to go all the way from meters per second to kilometers per hour. And he was going at 486 kilometers per hour, which meant, and George has been, yeah, that is incredibly quick, George. The only time you'll ever be going at 486 kilometers per hour, unless very fast cars or boats are invented in the future of your life, it's probably when you're flying on holiday somewhere. So you'll be travelling at that speed when you're in an aeroplane. But Donald was doing it on a lake in his boat, and he had just cracked the world record. So he'd just beaten the world record, 480 kilometers per hour. So I know this was a little bit of math here. This last bit was a bit tricky for some people, I'm sure, but it's worth a look if you can have a look back at it and see if we can understand how we did it. So to turn meters per second into kilometers per second, we divided by 1,000. To then work that out in kilometers per minute, there are 60 seconds in 1 minute. So we times that number by 60 to get to this number here. And then to work that into kilometers per hour, we times that by 60 again to get to 486, and that's kilometers per hour. So, and that shows us that he broke the world record.